Hi, today we're going to start talking about scientific notation. Right now, pause the video if you do not have a calculator in front of you and go get yourself your scientific calculator because you will need it for today's lesson. So what is scientific notation? Scientific notation is the shorthand way for writing very large, very large, or very small numbers. In chemistry, when we talk about atoms, atoms are so tiny that we don't talk about them as individual atoms. If we did, we would be in physical chemistry. We'd be in a junior level chemistry course in college. We talk about them generally as a big group. And to do so, in order to be able to talk about them properly, we need to talk about them in terms of scientific notation because they're so small that any mass of them is going to have a large number of atoms. So it's very useful in chemistry. So your scientific notation comes with two parts. You have your coefficient and you have a power of 10. So your coefficient is any number between 1 and 9, not 10. 1 and 9. And then your exponent can be either positive or negative. Let me show you what that looks like. Okay, so if you want to convert a number to scientific notation, all you're doing is moving the decimal until there is one digit to its left. What that means is if you have one number, then a decimal, and then maybe some more numbers. Okay, so you want to move the decimal so it's after the first non-zero digit. And the number of places that you move the decimal is what's going to be your exponent. Okay, so if your original number was larger than 1, then you're going to have a positive exponent. If your original number was smaller than 1, then you're going to have a negative exponent. So for instance, 2,367. Right now, we imagine that the decimal is after the 7. You don't see it there, but there's a decimal there. We want to put this in scientific notation. So we need to put the decimal in the spot right after the 2. So we need to make the number 2.367. Okay, so now we have to figure out how many spots did we move that decimal. It started behind the 7 and we moved it 1, 2, 3 spots past the decimal. We went from here, we went 1, 2, 3 spots past the decimal. So your number is 2.367 times 10. Now we got to figure out if those 3 spots is positive or negative. Well, go back and look at your original number. Is your original number larger than 1 or smaller than 1? 2,367 is larger than 1. So our exponent will be positive. We moved 3 spots and it's positive. Now let's look at the other example. You have a number 0.0856. We want to put this in scientific notation. So we want this decimal right here to move after the 8. You move it after the first non-zero digit. So you get the number 8.56 times 10 to the something. So we got to figure out what that something is. So how many spots did we move that decimal? We moved it 2 spots. So we put times 10 to the 2. Now we have to figure out whether that decimal that exponent is positive or negative. Well, if your original number was smaller than 1, and this is smaller than 1, then it's going to be negative. So now let's practice. We're going to do these problems on the document camera. Okay, let's do some examples. Let's start with the first one. We have the number 41,000. So we want to have this number look like 4.1000 times 10 to the something. We want the decimal to be after the first digit. Okay, so where is the decimal right now? The decimal right now is right there. We can kind of imagine it being there. So we need to move it. 1, 2, 3, 4.
We moved it 4 spots. Okay, now we got to figure out if this is positive or this is negative. Well, we moved it 4 spots. Is this number greater than 1 or smaller than 1? Because it's greater than 1, we have a positive exponent. Okay, let's look at the next one. We want to have this number be 2.9 times 10 to the something. So we need to identify where that decimal is right now. The decimal is right here, and we want to move it over here. So we're going to do 1, 2, 3. We moved it 3 spots. Now, is it positive or is it negative? Well, the original number is less than 1, so this would be negative. And that's your scientific notation. Now let's look at the next one. We want this number to be 6.0007000 times 10 something. Okay, so where's the decimal right now? It is over here. So how many spots do we move it? 1, 2, 3, 4, 5, 6, 7. It is positive because the original number was larger than 7. Sorry, larger than 1. Okay, let's look at this one. We want this number to be 1.32 times 10 to the something. Where is the decimal? It's over here. How many spots are we going to move it? 1, 2, 3, 4, 5, 6, 7. Oops. 7 spots. Let me just double check. 1, 2, 3, 4, 5, 6, 7. 7 spots. Okay, now we got to figure out positive or negative. Well, the original number was less than 1, so that is negative. Okay, let's look at the very last one. Our decimal is right here. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8. We're going to get 1.23 times 10 to the negative 8. 10 to the positive 8, because that number was larger than 1 to begin with.
Okay, now we're going to go in the other direction. So what if you have something already in scientific notation and you want to convert it back to what's called standard notation, the big number? So all you're going to do is you're going to work in reverse. You're going to move the decimal back to where it originally was, and your exponent will tell you which way to move. So if your exponent was negative, your exponent is negative, you're going to move the decimal places, you're going to move to the left. In other words, you're going to make your number smaller than 1. Remember, a negative exponent is smaller than 1. Negative is an original number, -1. So if your exponent is negative, you are going to move to the left to make your number smaller. If your exponent is positive, you are going to move the decimal to the right that many spots to make that number bigger. Okay, so we're going to practice these guys right now on the document camera.
Okay, so let's start practicing. Let's first review what we've learned already. Let's put the very first one in scientific notation because it's in standard notation. So this very first one should be 2.4 and then a bunch of zeros if we're dealing with significant figures, which we'll learn in a minute. 2.4 times 10 to, let's see how many spots we moved. 1, 2, 3, 4, 5, 6. We moved 6 spots because that number is bigger. Because that number is bigger than 1, then our exponent was positive. And if you notice, I wrote micrograms at the end. Remember, anytime we have a number in chemistry, we need to have a unit. So this is 2.4 times 10 to the 6 micrograms. We'll learn our prefixes tomorrow or the next class period. Okay, so now we have a number that is in scientific notation, we want to put it in standard notation. Okay, so this 2 right here says we're going to move our decimal 2 places. We're going to move our decimal 2 places. Because it is positive, that means our original number should have been larger than 1. Because it's larger than 1, we want to move to the right. So we're going to move to the right 2 places. 1, 2. So you end up with 389.40 centigrams. I moved 2 times to the right. Okay, now we have 7 times 10 to the minus 5 kilometers. Okay, we're gonna move the decimal, which right now is right here. We're gonna move the decimal 5 times, and it's negative, so we need to make a number smaller than 1. So we're gonna move to the left. Decimal is gonna move 1, 2, 3, 4, 5. Okay, so I like putting a 0 before my decimal. Okay, so I've got a decimal right here. Anywhere there's a loop, we need to fill it in with zeros. So we've got 1, 2, 3. We got 4 loops. 1, 2, 3, 4. And the 7 kilometers. So now we're in standard notation. 6.2 times 10 to the 4. 4 is positive, so we're going to move to the right 4 times. 1, 2, 3, 4. So that's going to become 62000 millimeters. Okay, and the very last one says 3.89 times 10 to the 0. Okay, how many times are we moving the decimal place? 0 times. It's telling you you're not going to move it at all. So it's going to be 3.89 liters. That's what it is in standard notation.
At this point, I would like you to pause the video and see if you can practice doing all of these problems here. At the very top, you have going into scientific notation if you're given a number in standard notation. And at the bottom, you're given standard notation. Sorry, you're given scientific notation and you need to put it into standard notation. The next slide will show the answer. So you can pause. Once you finish this, then you can check it on the next slide where the answers are. I apologize for the quality of this. You can ignore the numbers that are in parentheses at the top. We will talk about that next, but it shows you how to put things into scientific notation. And I've put it in what's called the appropriate significant figures, but we will discuss that in a minute. So pause here so you can check your answers. Okay, it is calculator time. Pull out your scientific calculator that you purchased so that we can get to know the calculator a little bit. So it's very hard to help you on your calculator. Everyone's calculator is different. So after this little slide, if you're still having trouble entering things, please come to a tutorial where I can help you one-on-one because I cannot help you during class time one-on-one. Okay, so first thing you want to do is try entering 37,000 times 7,000. So you see, and then equals, and it should give you a number. And you want to see something in scientific notation looks like on your calculator. If you do not get 2.59 times 10 to the 8th, then something happened. Okay, it might look like 2.59 e to the 8th. If that's the case, then that is correct as well. That is another way of writing things in scientific notation using the E button, which brings me to how you enter things into your calculator. If you have one of the more expensive calculators, you will be using the EE button or the exponent button. So you should pause the video right now to find your EE button or your exponent button. That will replace the times 10 to the whatever. So if you want to enter 2.59 times 10 to the 8th, you would do 2.59 EE 8 or 2.59 exponent 8. Some of the calculators have a times 10 to the whatever button. If you have that button, you may use that as well. The one thing I do not want you to do is actually manually enter times 10 to the little caret and then the 8, because you will make mistakes. If you choose to enter that way, you need to make sure you always have parentheses around your entire number. So if you wanted to enter it as times 10 to the little caret up, for instance, for the 2.59 number, you would have to put parenthesis 2.59 times 10 caret up 8, then close parentheses. If you do not put those parentheses when you're doing division, you will make mistakes and your answers will be wrong every single time. So you need to spend a little bit of time with your calculator figuring out how to enter things into it. Okay, so here are a couple of problems so you can see the sort of answers you should get. Okay, now we're going to go into significant figures. Significant figures are incredibly important in science. And why is that? And significant figures are the numbers that matter in science. When you do a calculation, many times you get 10 digits on your calculator, but not all of those are appropriate. And you guys are always like, what should I round to? Well, your measurement will tell you what to round to. It's not a set rule, always go to 2 decimal places. No, it depends on your measurement. Okay, so what that means is that there is uncertainty in all measurements. Remember we talked about accuracy and precision? Those give you uncertainty in your measurements. And so you cannot say your number is better than your uncertainty. So the certain digits, the numbers that we are certain about, that we have no question about, are read directly off the measuring device. And then we add one extra estimated digit. So you have, what significant figures are, is you have the numbers you are certain about, then plus one guess. Your very last digit is a guess. So if you were to look at this graduated cylinder and you want to measure how much water is in this graduated cylinder, you would go to your graduated cylinder. This is the 50 mark. This is the 60 mark. So we know we have 50, 51, 52, 53, 54, 55, 56. We know for sure, we have 56 milliliters. But we probably have maybe a little bit more or a little bit less. So this last digit right here, we're saying this is exactly 56.0 milliliters. You might say it's 56.0, and I might say it's 56.1 milliliters. And those are both correct, because what a significant digit does is it tells you, I am certain about these ones, and the very last digit, that's the one that is my estimate. That is my guess. Okay, so you need to know what your significant figures are. Okay, the amount of definite digits depend on the measuring device. Okay, so on your graduated cylinder, on your ruler, on your scale, they're the ones who are going to determine your significant figures, the definite numbers. The exact number, if you have an exact number, like if I say you have 25 people in this room, they have an infinite number of significant figures because it's exactly 25.000, lots of zeros, because you can't divide up a person, right? So if you have a exact number like 25 people, that has an infinite number of significant figures. Otherwise, we have to determine it from our measurement device. Okay, then we have some conversions. Those are also considered to be exact. We know that exactly 12 inches is equal to exactly 1 foot. These conversions are also infinite. We know that exactly 100 centimeters is equal to 1 meter. Those are also considered to be exact, so they have infinite significant figures. I've posted some videos on significant figures for you to go through as well. So if you need a little more help than what I'm doing right now. Okay, so your significant your significant figures indicate a precision of a measurement, how good a measurement is. So if you're recording your significant figures, it's going to include the known digit plus the final estimated digit. So if you're trying to measure this, paperclip, we know that it is, we can draw a line there and we say, we know that it is 2.123. We know for sure it's 2.3 centimeters, but it's not exactly 2.3 centimeters. If you look, it's a little past that exact point. So I'm going to guess it's 2.33 centimeters. But you measure it, your eyeball might say, no, I think it's about 2.34. Somebody else might say, no, I think it's 2.31. All of those are correct because the digits you are confident of, the 2.3, that hasn't changed for anybody. The only thing that has changed is that final estimated digit. So a significant figure tells you that you are confident in the first digits. It's the last one that is kind of a guess. So it gives you some parameters to understand the numbers that you have. So there are a bunch of rules for determining significant figures just by looking at that. And it's important that you know them, and they are in the next few slides. However, I'm going to teach you a way of remembering them. I teach you a way of determining them without actually having to know the rules, but you should read the rules so you understand them. Okay? So this is an easy way to remember how many significant figures a number has. So the first thing you do, and we're going to do examples, so this will make sense in a minute. The first thing you do is you think of the United States. All right, here's Texas, here's Florida, New York's up here, here's California. But what you have on the left side of Texas is the Pacific Ocean. What you have on the right side of the United States is the Atlantic Ocean. So the Pacific is on the left, the Atlantic is on the right. So if you were to get a number and you see a decimal is present, you are going to start on the Pacific side. Present, Pacific, present, Pacific. You're going to start counting on the Pacific side, in other words, on the left side of the number, from the first non-zero digit. Okay? And then you're going to, once you hit that first non-zero digit, you're going to start counting from the left, and you're going to keep counting until you run out of numbers. And that'll tell you how many significant figures are in a number. If you have a number and the decimal is absent, you're going to start on the Atlantic side. The Atlantic side is on the right. From the first non-zero digit, and you're going to count all the digits to the left of it. So you're going to say, is there a decimal? Oh, there's no decimal. Let me go to the right side of the number. Look for the first non-zero digit going from the right. Once you find that, then you start counting. So we're going to do some examples so this makes sense. Okay. For instance, right here, first number, 23.50. First thing you ask is there a decimal present? Is there a decimal present? Yes, there is a decimal present right here. Okay, so because it's present, we're going to go to the Pacific side, the left. We're going to find the first non-zero digit we encounter. Oh, that's the 2. Now we can start counting. Once we start counting, we cannot stop counting. This has 1, 2, 3, 4. 4 significant figures. Okay, so this one has 4 significant figures. Now let's look at this number. 402. Is the decimal present or is it absent? Well, in this case, the decimal is absent. Absent like Atlantic. The Atlantic is on the right. So we're going to start from the right counting. We're going to look for the first non-zero digit we see. Oh, not 0. So we're going to, once you hit the first non-zero digit, you start counting. Once you start counting, you cannot stop counting. So 1, 2, 3. This has 3 significant digits. Okay. So those are straightforward. Now let's look at this one. Is there a decimal present or absent? Well, I don't see an absent. I don't see a decimal here at all. So it is absent. So if it's absent, you go to the Atlantic side over here. And you're going to start counting from here, from the first non-zero digit. Oh, it's a 0. Can't count him. Oh, my first non-zero digit. So I can start counting. Once I start counting, I can't stop. 1, 2, 3. This number has 3 significant digits. Okay, last one. Is there a decimal present or absent? It is present, so we're going to count from the Pacific side or the left side, from the first non-zero digit. So we're coming from the left. Oh, it's a 0, can't count it. It's a 0, can't count it. Oh, here's my first non-zero digit. I have to start counting. Once I start counting, I can't stop. 1, 2. This has 2 significant figures. Okay, so we're going to go through all the rules. I'm going to just go right past them so you know that they're there and you can go and look at them on your own time. These are the rules that explains why the Pacific Atlantic rules work. But these are the rules that normally you'd have to memorize. But the Pacific Atlantic is to kind of give you a mnemonic to remember it. Okay, so again, decimal present, you count from the Pacific side, the left side, from the first non-zero digit. Once you start counting, you can't stop. If a decimal is absent, like Atlantic, you're going to go from the right side. You're going to start counting from the first non-zero digit. And once you start counting, you can't stop. Okay? So to sum it up, decimal present, counting from the left. When you hit the first non-zero number, if there is not a decimal present, it's absent. You count from the right when you hit the first non-zero number. Remember, once you start counting, you cannot stop until you run out of numbers. Just keep counting, just keep counting. Okay, so there's a little quiz for you to do when you run through the Nearpod. But let's just do this first one so you can see it. 4.59. That one is 3 significant digits. There's a decimal present. We count from the left. 1, 2, 3. Okay. So here, these are the same problems. You should run through them. Number 2, there is a decimal present. We count from the left, from the first non-zero digit. That's the 3. We're coming from here. Once we start counting, we can't stop counting. 1, 2, 3. Okay, let's look at this one. Number 4. We're going to count from the left again because there's a decimal present. We're counting from the Pacific side, from the first non-zero digit. Oh, we're coming from the left. Can't count him. He's a 0. Can't count him. He's a 0. Can't count him. He's a 0. So we start with the 5. Now we're going to start counting. Once we start counting, we can't stop. 1, 2. 2 significant figures. This guy, 43,000. No decimal present, so we come from the right. Can't count him. He's a 0. Can't count him. He's a 0. Can't count him. He's a 0. Oh, first non-zero digit, we start counting. Once we start counting, we can't stop until we run out of numbers. 1, 2. Okay. Then here we have something in scientific notation. When you are counting things in scientific notation, you ignore the exponent. You just look at the number. Ignore the exponent. Just look at the number. And you use the same rules. This is 3 significant figures. Quick way of figuring out how many significant figures something has, put it in scientific notation. Okay, so now you should pause and put these in scientific notation and then determine the number of significant figures. Okay, so here they are. You should pause over here to practice. Sorry. You should pause right here to practice. See if you can put them in significant figures. Scientific notation, and then determine significant figures. On the next screen will be the answers. Okay, 41,000 becomes 4.1 times 10 to the 4. That has 2 significant figures. 0.029 times 10 to the minus 3 has 2 significant figures. Number 3, that one has 5 significant figures. Number 4 has 3 significant figures, and number 5 has 3. Significant figures require practice. Practice, practice, practice. I will upload a worksheet for you to practice with an answer key attached so that you can check your work. Please come to tutorials if you have a hard time. Okay, so here, again, pause the video so you can practice and see if you can calculate how many significant digits are in each measurement. And the next thing says to round the measurement to 2 significant digits. And we're going to talk about rounding in a minute. Okay, so pause here, try to do the top part. Once you've done the top part, you can move on to the next page. And here are the answers. You can pause here and check it as well. Okay, so that's just a summary, which you can go through on your own. So now we're going to get to rounding. We're going to get to math using significant figures. So what you need to do when you're rounding, these are the same rules you've always had. First thing you have to do is figure out how many significant figures your answer should have. And that's going to depend on the given measurement and the math process that we need to solve. Okay? You're going to round to that many significant figures, counting from the left. If the digit immediately to the right of the last significant figure is less than 5, you're going to drop it. You're going to drop the value, otherwise you're going to go up. So what does that mean? Okay. So let's look at this. Let's look at 56.312. If I tell you to put that to 4 significant figures, you're going to make it 56.3, and then we have to figure out whether that 1 should be a 2 or does it stay as 1. So you look at the number to the right of it. The number to the right of it is a 2. Therefore, the 1 stays. It stays as 56.31. Now, if you had 56.316 and I asked you to round it to 4 significant digits, you would write 56.3. Now you'd look at that 1 and you say, okay, the guy to the right, is it bigger than 5? Is it 5 or bigger, or is it less? Oh, it's bigger. So that 1 is going to round up to 56.32. Okay. So then there is a quiz where you practice, and you should do them. It'll tell you the right answer once you do it. Now we're going to look at sig figs in calculations, and this is where a lot of you mess up. So pay attention, make sure you take good notes, and practice, practice, practice. Again, I will put up some worksheets for you to practice that, and then with answer keys. So what you need to do, if you're talking about addition or subtraction, what is important for significant figures in addition or subtraction is the decimal places. How many decimal places you have. So the number that has the least number of decimal places are going to determine how many decimal places your answer should have. The one that has the least number of decimal places will determine how many decimal places your answer should have. This is for addition and subtraction only. Addition and subtraction only. So for instance, 5.7 plus 2.11. You add those up, you get 7.81. But we can't just leave it as 7.81. We have to put it in the right number of digits. Because this is addition or subtraction, we look at the two numbers we started with. 5.7, that has 1 decimal place. 2.11 has 2 decimal places. 1 is less than 2, so your final answer must be 1 decimal place. Okay, let's look at the other example. 7.12 minus 1.345. You enter that into your calculator or you do it on the paper, and you get 5.775. Okay, so this is subtraction, so we're looking at decimal places. 7.12 has 2 decimal places. 1.345 has 3 decimal places. 2 is less than 3, so your answer must be in 2 decimal places. So you end up with 5.775. You need to put that in 2 decimal places. So you look at the second 7, you look at the guy to the right of him. He's a 5. That's going to make it's going to make you round to 5.78. You're using the rounding rules here as well. Okay? So when you're doing addition and subtraction, you are looking at decimal places. Addition and subtraction, you're looking at the decimal places. The one with the least number of decimal places determines how many decimal places your answer will have. Okay, the fact that I'm making a big deal that this is addition and subtraction means that multiplication and division are different. Please do the quiz on the Nearpod when you get a chance. Okay, multiplication and division. You're going to look at the total number of significant figures. We're not looking at decimal places anymore. We're looking at significant figures. Okay, you're going to go with the one that has the least number of significant figures. So let's look at example number 1. 17.85 divided by 2.13. You enter that into your calculator and you get this number right here. We can't put every single digit because they're not, these guys don't, a lot of these numbers don't have any significance. We need to make sure we have numbers that have significance. So what we're going to do is we're going to look and we're going to see how many significant digits there are in each of these. So this guy right here has 1, 2, 3, 4. 4 significant digits. This guy has 1, 2, 3. 3 significant digits. 3 is less than 4, so your answer must be 3 significant digits. So out of this whole big number, you can only write down 8.38. The number next to the 8 is a 0, so the 8 remains. We do not round up. Now let's do a multiplication problem. This is what we use a lot in this class, multiplication and division. So if you're doing multiplication, we have 1, this guy. Wait, you enter all this into your calculator and you get this big number. How many significant digits are in this number? Decimal is present. So we're going to go from the left. Can't count, can't count. 1, 2, 3. This number up here has 3 significant digits. This number down here has 2 significant digits. Because it's got less, this has 2 significant digits and this has 3 significant digits, we are going to go with an answer with 2 significant digits. So that means this isn't significant, this isn't significant, this isn't significant. We're looking at this right here, that 1/6. So we're going to put the 1 down. The 6, we don't know if that 6 is going to be a 7 or does it remain a 6. Well, you look at the guy next to him. The guy next to it is an 8, which makes this guy go up. Your final answer is 0.0017. All of your answers in chemistry must contain significant digits. Okay, there is going to be a worksheet 1 and worksheet 2 will be placed in Schoology, and the answer keys will be posted. Please, please, please practice and come get help if you don't understand. This is very, very important, and I know I've gone through it quickly, and I'm not there to walk you through it in person. There's also additional videos I have posted under online resources within the course. Please look at those as well. The more you practice, the easier it'll get. It requires practice, and it's very, very important. Chemistry builds. Everything you do will continue building from one to another, from one unit to another. So you need to learn it now because next unit you'll be lost. And the following unit you'll even be more lost. We build. Okay? If you have any more questions, please ask. Thank you.